Alright, let's get started. So power series. The idea behind power series actually goes all the way back to a geometric series. So you remember with a geometric how we had something like that. N equals 0 to infinity of 1/3 to the n. Now, you can rewrite this as the way that the book did at the beginning of this chapter when we were doing the geometric series, how they always made it n equals 1. For power series, it's probably good just to get used to the fact that this is a geometric series. It's just another way to define it. And it's a lot more helpful when we get into power series. So for this one, what's your R? 1/3 is your R. To find your A, I don't know if you guys remember, A is actually equal to the first term in the sequence, or the first term you would add in the series. How would you get the first term? What do you do? Plug in whatever this is. So plug in 0, what do you get? 1. So A in this case would be 1. Now you remember when you have a geometric series and this is less than 1, or the absolute value of that is less than 1, this is equal to what? Yeah, the general form is you have some r to the n, and it's equal to a over 1 minus r. That's the general idea behind the geometric series. For this one, your r is 1/3, and our a is the first term, so that's going to be 1 over 1 minus 1/3. Everyone follow me there? Makes sense? Now, when we get into power series, what we start doing is we look at things that look like this. And what you should recognize is that this, if x happens to be less than 1, or the absolute value of x happens to be less than 1, this can actually be written as a series, using the same kind of idea. What would be my a in this case? 1. What's my r in this case? X. So the series goes n equals 0 to infinity of x to the n. You can check yourself. If you plug in 0, what do you get in here? 1, which is my first term. Is that my first term? That's my a. So this and this is where a lot of power series starts. This is a very basic form of a power series. As you write this out, how would it look? If you wrote out this line.
1 plus x.
1 plus
X.
X plus
X squared.
X squared plus X cubed plus X fourth. On and on and on and on. Forever. The key to figuring out power series is you've got to be able to go from here to here, from here to here, back to here, over to there. You've got to get fluent between the different representations. So you've got to be able to go from something that's written like this to a series, and then if you can recognize that series as being geometric, then you can go to here. But this is only true when x, the absolute value of x is what? Less than 1. Otherwise, this, so if we let f of x equal that, you can actually find something like f of 1/3. Because all that is plugging 1/3 into here or 1/3 into there, which is 1 over 1 minus 1/3. But could you use the series to represent f of 2. Yes.
If you changed where it was centered, you could.
If you change where it was centered, you could. That is correct. So if you changed the center of your power series, then you would be able to do that. But as it's now written, it's not going to help you. The only time it's going to help you is if x is less than 1 for this power series. Does that make a little more sense? It's all connecting back to geometric. It's all going back to here.
So do we need to know how to write so we can do FX?
We will probably look at an example later.
But not like this one.
Not right now. No, I mean like, not later in this review. We're going to get to that. So, we're actually going to look at the problem I got on the online homework. We're going to go through all 4 problems. So, the problem I got was to write 6 over 1 minus 3x as a power series. The key for these is to recognize, is this in this form? It actually is. We've got an A. What's our A? 6. Do we have a 1 here? Do we have a minus something? Or what is that something? So what's my R? It's 3x. So if I wanted to write this as a power series, that's going to go n equals 0 to infinity of, I should have put A in here. Okay. Your A value, what's your A value? And my R value is 3x to the n. So it's tying geometric series to something with an x in it. And it's really kind of odd, because when you're thinking about the series, is x getting affected at all? No, it's the n that's really getting affected. When we start doing derivatives and integrals, though, do the n's really get affected? It's the x's that you're taking the derivative or the integral of. So it gets a little tricky because you have to go back and forth between x is fixed, and then when you're taking the derivative, it's like n is fixed. It's weird. It messes with your brain, but as you get used to it, as you work more with this, it gets a little easier. So that is actually our power series right here. We've got a power series. Now, on the online homework, it asks for things like this, c sub 0. Now, the confusing thing on the online homework is this is not the first constant necessarily, or the first coefficient necessarily. What this is they're saying c sub 0 is your constant term, c sub 1 is the one that's with x, c sub 2 is the one that's with x squared, c sub 3 is the one that's with x cubed, so on and so forth. So, c sub 0 is our constant term. Let's write out the first few terms of this. If I plug in 0, that's going to be 3x to the 0, which is 1 times 6 is 6. Plus, what's the next term? Plug in 1. That's going to be 18x. Plug in 2. It's going to be 9x squared times 6, which is 54. X squared. How far do I need to go? Oh, it all wants all the way to C4. All the original there. So the next one, you're going to have 3 cubed, which is 27, times 6, which is
162, sound right?
25. the next one. The next one would be 486, x to the fourth, plus dot dot dot. We don't need to worry about anymore after that. Because all they're asking is, what are these? So c sub 0 is your constant term. What do we got? C sub 1 is the coefficient on your x term, which is 18. The next one is 54. The next one is 162. The next one is 486.
So you're just taking the coefficients.
Yep. So on the online homework, that's all they want you to do. Now, what gets tricky is on some of them, you actually get things like x cubed, x to the fifth. You don't actually get the constant term or the x squared term. So when it says c sub 0, that's not the coefficient on the x term, that's the coefficient for the constant. And if there is no constant, then what do you put? 0.
So even if it's just x squared for that part, I just would have thought that c sub 2 would be 1, but it's 0.
If it was x squared?
Yeah.
No, it would be 1.
Okay.
And the last thing that they want you to do is figure out the radius of convergence. What's your favorite way to figure out radius of convergence? Do you want to use ratio test? That's fine. That's what I would use. So that's going to be 6 times 3x to the n plus 1 over. We're going to do the limit as n goes to infinity to the value. 6 times 3x to the n, which is going to leave me
3x.
the absolute value of 3x. And I want that what? Less than 1. Now remember, when you're looking for radius of convergence, you want it in some form like this.
This is part of
Less than r. Now we don't have an x here, we have a 3x, so what could we do? Divide by what? 3. Both sides by 3, that's going to give me,
As n approaches infinity, the absolute value of x is less than 1.
so the absolute value of x is less than 1/3. Where is my center then, if they asked that? 0 is your center. There's no a there, so it's just 0. And my radius is 1/3. Yes.
Do we have to do the ratio test, or can we just look at that
No.
and say that 3x?
You can say that the 3x is inside the geometric. It gets a little trickier when you start taking derivatives and things because you're going to get n's and n plus 1s.
Okay,
Then
so
you have to
ratio
use-
test is the more.
Yeah, if you use the ratio test just kind of constantly, then it's usually going to come out.
So we don't have to show it on our homework though, right, the ratio test?
No.
If this was on the, if this happened to be on the test, would we need to say that the radius is 1/3 by the ratio test?
I don't think so. I think you'd be okay. So that was the first question. That one's actually not too bad. It's just recognizing that you've got pretty much a geometric series. Now the next one I got was 7x over 3x squared plus 1. And they wanted you to write that as a power series. So, your first goal really is to make sure that you've got this bottom figured out. We want it to be something minus something. And we want the x to be over here, and we want a constant over there. I'm going to rewrite this as 1 plus 3x squared. How could I get this to be 1 minus something? I make this a negative 3x squared.
Will you ever have anything but 1?
It has to be 1 there.
Okay.
You have to make it 1. So we're going to get to a problem where it's not 1 and you got to change it. So we've got 1 minus a negative 3x squared. That's looking good. What about this?
That's a constant, right?
In this case, when you're writing the power series, you can kind of think of this as your constant, or it's your a. It's your a value. The 7x is just a. So now we've got a minus, or over 1 minus, what's that? For r. So now we can write that as a series. And it's all going back to geometric. So we're going to have a 7x times our r, negative 3x squared, to the nth power. Personally, as I was looking back on the book, I don't understand why they had you change it so that it was n equals 1 to infinity every time. Didn't make any sense for geometric series. So, because when we get to power series, you start using 0. So, other books actually don't do that. I don't know why they chose to do that. I apologize if that was confusing.
Yeah, when you take the derivative, though, doesn't it change it?
A little bit. Okay, so this one is, again, they want you to tell them what the coefficients are. Now, this gets a little tricky. The easiest way to do this is to rewrite this as 7x, and I'm going to split this up into 2. So that's going to be negative 3 to the n, and it's going to be x to the 2n. And to simplify more, I want to combine this x with this x. How can I do that? If I have x 2n times multiplied together and then I add one more x, what happens to the exponent?
7x plus 2n plus 1.
It's going to be 7 times negative 3 to the n, x to the 2n plus 1. Now to get your coefficients, because that's what we're looking for in this one, they want c sub 0, c sub 1, c sub 2, c sub 3. C sub 2n, c sub 2n plus 1. It's getting kind of crazy. So let's calculate the first few terms. I plug in 0. 2 times 0 is? So then I get plus 1, which is x to the first. And we get negative 3 to the 0 is?
1.
So that's going to be 7x. Now I'm leaving a space there because what is your constant term? If you write it out like this, you can kind of see that your constant term is actually going to be 0. So when it's asking for c sub 0 over here, what is that? 0. C sub 1 is actually 7. C sub 2, let's look at it. You plug in n equals 1, you got 2 times 1 is 2 plus 1 is 3, so that's x cubed. Negative 3 to the first is negative 3, so that's going to be negative 21x cubed. Did I do that right?
Yeah.
When n is 1, that's negative 21. So what do I have for an x squared term? 0x squared. So over here, when they're asking for c sub 2, that's actually 0, because there is no x squared. But your x cubed term is negative 21. Now, here's where we get a little tricky. We've got to think about 2n, the coefficient on c sub 2n. Meaning, what is the coefficient on some even power way out here?
0.
If you notice, even powers, this is to the 0 power, this is to the second power, what would be the fourth power?
Zero.
It's going to be 0. So any power that's 2n in the power is going to be 0. Because this series only has odd terms as exponents. Because 2n plus 1 is an odd number. So it's going to go x, x cubed, x to the 5th, x to the 7th, so on and so forth. It's going to skip over the evens. So any even coefficient is just going to be 0. Does that make sense? Now what about 2n plus 1? The trick is to recognize, hey look, here's my power that's 2n plus 1. So my coefficient on the 2n plus 1 term is whatever's left over, which is the 7 times negative 3 to the n. That one they actually do want the n in there. It's a formula. They're just saying that at x to the 2n plus 1 term, way out there, that's the coefficient that's on it.
This is almost recursive. You are defining c to the 2 plus 1 in terms of 7, 2, 3 again.
It's not recursive. Because recursive would be if this was dependent on the coefficient before. Sort of. Kind of is. Alright, last thing, radius of convergence. This is where it's going to start getting tricky and you've got to, I would probably try using the ratio test. Because things get a little messy. So take the limit, and then goes to infinity of the absolute value of 7 negative 3 to the n, x to the 2n plus 1. Oh, plus 1. That's actually going to be what? N plus 1 is going to replace n. All over 7 times negative 3 to the n, x to the 2n plus 1. Now here comes the tricky part. 7s are going to cancel. What's going to be left here?
Negative 3.
Is it going to be a negative 3? It's absolute value, so what's going to happen to that 3? We're just going to get 3. We've got x to the 2n, and I heard somebody say it's going to be 2n plus what? 3. 2n plus 3 over 2n plus 1. What is that going to leave me with? It's going to leave me an x squared. Absolute value, that's to be precise. And I think that's it, right? We want that to be less than, why less than 1?
It's only converging by the ratio test.
It's only converging by the ratio test when this limit is less than 1. So we want that to be less than 1. Divide by 3, that's going to give me x squared is less than 1/3. Now I don't want x squared, I want x. So what am I going to use? Square root of both sides is going to be x is less than the square root of 1/3. Weird radius, but that's what it comes out to be. Have I lost anybody so far? Are we doing good? Just making a little more sense on what they're looking for in the online homework and how it is related to geometric series. You're really always trying to relate it back to a over 1 minus r. That's what you're trying to get it to relate to. Next one. We got 3 over 2 plus x squared. Now, this one's kind of weird because they say, use differentiation. But the first step you actually have to take is not differentiation. You have to integrate first, and the reason why is because we don't want this square down there. What do we want down there? We just want, we want it to be the first power. So I'm actually going to say, let this be f of x. I'm going to integrate, and that's going to be big F of x is equal to, if it helps, rewrite this as 3 times 2 plus x to the negative 2. To integrate that, you're going to add 1 to the,
That's negative 1.
so it's going to be negative 1. Well, what's going to come out here? Now, if you're not sure, take the derivative and see if you get back there. Negative 1 times negative 3 gives me 3, and I subtract 1 from there. Oh, what about chain rule? The derivative of the inside is just 1, so it's okay. So now we've got, if I rewrite this, this is negative 3 over 2 plus x. It's looking a little better. We're getting closer to something that looks like a over 1 minus r.
That one.
But I don't want plus here. What do I want? Minus. So let's do that first. Negative 3 over, it's going to be 2 minus a negative x. But I don't want 2 here. That's where it gets a little trickier. One way you can think of this is pulling out a negative 3 from the top and pulling out a 2 from the bottom, which will leave me 1 over 1 minus negative x divided by. Now if you distribute everything through, that's going to be a negative 3. That's going to give me 2 minus a negative x. You see how you can make this a 1? Does that make sense, Michaela? Okay. Now is it in the form that we want?
Yes.
If you really want to get technical, we could write this as negative 3 halves on top like that. Just looks kind of weird.
So it doesn't really matter if that's out in front of the sum or.
Not really, because it's just a constant. What you have to be careful too is this constant is never to some n, it's just a constant. If you start putting it inside things with an nth power, you're going to get really wrong really fast. So just recognize that that's just a constant. So if I want to write that as a power series, it's going to be n equals 0 to infinity. What's my a? Negative 3 halves. What's my r? Negative x over 2 to the nth power. Now, is that the power series that I'm looking for? This is actually the power series for big F of x, but I'm looking for the power series of little f of x. So how do I get from here to the small f of x? I take the derivative of the power series. Now, this is where you've got to be careful. When I take the derivative, what am I taking the derivative with respect to? X. So anything that's like, if there was an n in here, would I have to worry about it? It just kind of acts like a constant when you're taking the derivative. We're only worried about what's in here. Now, you got to be careful. That's going to be n equals. Why does it go to 1? I don't know. Yes.
It's because when you write it out, you get a list of, kind of like over there how we were writing out the stuff, and the first one is a constant. So when you take the derivative of that constant, it goes to 0, and so it doesn't apply as a
Yeah. Does that make sense? I will memorize. Okay, let's just look at a really simple example. x to the n. That's going to be 1 plus x squared plus x cubed plus dot. Now, if I define that as f of x, f prime of x is going to be n equals, we'll think about that in just a second. What happens to a 1 when you take a derivative? It goes to 0. The next one is? The next one is 3x squared. So what ends up happening is you got n, bring that down, that's going to be n x to the n minus 1. Now if I started at 0, it actually doesn't buy me anything because the 0 term would be 0 times something, which is 0. I mean, that's where the constant's coming from. So what they do is they just skip that and they say, well, we'll start at 1 now. Because that's going to skip to this term.
Technically, would it be wrong if you wrote it from 0? It is the same sum.
I know.
Yeah.
Actually, the online homework doesn't like it when it's n equals 1. So I'm going to be showing you what they want you to do. Weird stuff. So that's why you kind of just skip to n equals 1. So this is going to go to n equals 1. That's infinity. We take the derivative of this. Correct. So we're going to have n. We're going to have this negative 3 halves. You're going to bring down an n. Then we're going to have negative x over 2 to the n minus 1. When you take the derivative, you subtract 1. Then we've got what? Chain rule. We've got to take the derivative of the inside, which ends up being negative 1/2. Now when you want to write the formula for this, it's probably good to try and simplify it a little more. You're going to do, the first thing you've got to do is change everything to 0 actually.
So if we subtract 1 on the series, and then you just add 1 to the inside stuff, that's confusing. So you're changing n equals 1.
So n equals 0. N equals 1 would give me 1 times this to the 0 power. So if I want that to the 0 power and I'm starting at n equals 0, that's going to be negative x over 2 to the nth power. You see how that works? You're actually right. When you take away 1 from this n here, you add 1 to everything that's in here that has an n. So then this is going to become what? n plus 1. And I'm actually going to combine the negative 1/2 with the negative 3 halves, and that's going to give me 3/4. Gotta make sure I'm doing this right. The last little simplification I would do, because they ask for the nth term constant, it's actually good if you pull out a negative 1/2 to the n, so that you can see what the constant is. It's 3/4 times n plus 1 times a negative 1/2 to the nth times what? What's left? X to the n. Now you've got it written in a simplified enough form that you can see what each term is going to have. So then we've got that C sub 0, C sub 1, C sub 2, C sub 3, and then the C sub n, I think, is what we're looking for. Okay. So C sub 0 is going to be what? It's just when you put n equals 0 into here. So that's going to be 3/4 is all I'm going to have, because 0 plus 1 is 1. That to the 0 is 1. That to the 0 is 1. So that's just going to be 1 times 3/4. 3/4. C sub 1 is going to be when you plug in n equals 1. It's going to be x to the first. Negative 1/2 to the first is negative 1/2. 1 plus 1 is 2. So that's going to be 2 times negative 1/2, which is negative 1 times 3/4, negative 3/4. C sub 2, 3 times 3/4, 9/4. Negative 1/2 squared, 1/4, so that's 9/16. Okay. And then C sub 3 is just going to be 3/4 times 4 gives me 3. Negative 1/2 to the third is negative 1/8, so that's 3 times negative 1/8, which is negative 3/8. And your C sub n is then just 3/4 times n plus 1 times a negative 1/2 to the nth power. Because x sub n, or x to the n, is that term that we're looking for, and the coefficient is just that. Does that make a little more sense on what they're looking for on the online homework? I found it really confusing. It took me a long time to figure out what they were doing. I spent like the whole morning trying to do this. So, radius of convergence of this one. What are you going to use to find the radius of convergence? You want to do ratio test? That's what I like. I'm a little... There are times when you might want to use the root test. It's not as often. Absolute value of 3/4 times n plus 1 plus 1 is going to be n plus 2 times negative 1/2 to the n plus 1 times x to the n plus 1. All of that over 3/4 times n plus 1 times negative 1/2 to the n times x to the n. Which, when I simplify that, what does that leave me with? So it's going to be n plus 2 over n plus 1. We're going to have a negative 1/2 on top. But because the absolute value is, what's that going to do? It's going to be 1/2. And we're going to have an x on top. The limit as n goes to infinity of that goes to where? 1. So I actually end up with, oh, I forgot the absolute value of x. 1/2 absolute value of x is less than, what do we want it less than? 1. So the absolute value of x is actually less than 2. So what's my radius? 2. And my center, just 0. Center is 0.
So if you have x minus 5 and it's greater than, or something, then your center is 5. And
Correct.
if x is plus 5, then you negative 5.
Correct. Everyone get that? Say you had, when you got down to the end, you had x minus 5 is less than 1. What's my radius? 1 is my radius. What's my center? 5. What if I had x plus 5 is less than 1? My center would be negative 5, radius would still be 1.
Oh, but, -4 to 6 is like your interval convergence.
Correct.
Okay.
If it was like 3x plus 5, your center would still be -5.
No.
No.
So if you got, that's a good question. If you end up with something like this, 3x minus 5 is less than 1. You always want to get it into some form of x minus a is less than r. This is not an x, this is 3x. So the way that we can get it to be x is we divide everything by 3, which will give me x minus 5/3 is less than 1/3. So then your radius is what?
1/3.
1/3, and your
Your
center
center is
is 5/3.
Okay.
Sorry. The next question that they ask on the online homework is, given that you just found f of x is equal to the series n equals 0 to infinity of, where are we at? 3/4 times n plus 1 times -1/2 to the n, x to the n. So given that you have that, find wants us to find a power series for 3 over 2 plus x cubed. Now, what you got to recognize is that what is f of x actually? The function that they gave us at the very beginning. 3 over 2 plus x squared. So this is actually equal to 3 over 2 plus x squared. Now, let's say I take the derivative, f prime of x. What is that equal to? When I take the derivative of this.
-3x. 1 over 2 to the third.
Because they're all trying to do it in your head. Come on, pull out a piece of paper. 2 plus x to the -2. Take the derivative, that's going to be -6 times 2 plus x to the -3rd. So that's going to be -6 over 2 plus x cubed. Now, is that what we're looking for? Almost. How can I get the -6 to be a 3 though? If I multiply by a -1/2. Multiply this by a -1/2, which means I then need to multiply this series when I take the derivative by -1/2. So we're going to take the derivative of this. What do we have to worry about in here? Just to the x to the n. That's the only one that we really need to worry about. So that's going to give me, oh, except this is going to go to 1 again. So that's going to give me 3/4 n plus 1. I'm going to bring down an n times -1/2 to the n, x to the n minus 1. Jackie, you bit your lip. Does that confuse you?
Well, no, just the
Oh. Be careful, yeah. We're taking the derivative here. So that is going to give me, I'm going to bring in the -1/2 into here. So that's going to give me n equals 1 to infinity of 3/4 times n plus 1 n times -1/2 to the n plus 1, because I have a -1/2 and another -1/2, x to the n minus 1. Yeah. But now they don't want you to start at n equals 1 on the online homework. Where do they want you to start? N equals 0. So we're going to change this to n equals 0. If I take 1 away from this n, what do I do to all the n's in here? I have to add 1. So that's going to be 3/4 times n plus 2 times n plus 1 times negative 1/2 to the n plus 2 times x to the n. And now that I have that all written out, I can find all the c sub 0, or actually it's d sub 0.
Sorry.
Yes.
When you change it to n to 0, all the other ones you
No,
add
why is it
one is what we got first. So we did
Yeah.
and the bottom is q.
So if I take away 1 from this outside 2, you can see that these are equivalent statements because if you plug in 0 into here, 0 plus 2 is 2. If you plug in 1 into this one, 1 plus 1 is 2. Plug in 0 into that one, 0 plus 1 is 1. Plug in 1 into that one, that's 1. Plug in 0 into here, that's 0 plus 2 is 2. Plug in 1 into there, that's 1 plus 1 is 2.
Does it work the same way if I wanted to go from 0 to 1? I would just subtract.
Correct. So if you were going from 0 to 1 in the series, you would subtract 1 from it. Now, if you wanted to figure out your d sub 0, that's the constant term on the x to the 0 term. That's going to give me plug in 0 into here. 0 plus 2 is 2. 3/4 times 2 is 3 halves. 3 halves plus, that's going to be 1. 3 halves times 1 is 3 halves. Negative 1/2 to the second power, 1/4. So that's 3/8 is going to be. If you have to, I'm not writing it out just because I'm trying to save space on the board. But I would like write these out. What is the constant that you get on the x to the nth term? So d sub n would be what?
All of that.
It's just all of this. 3/4 times n plus 2 times n plus 1 times negative 1/2 to the n plus 2. Plug that into the computer, and you're good to go.
So the online homework's due at 10, is that right?
I'm going to move it to tomorrow.
Okay, sweet.
Everyone's like Friday's homework tomorrow.
No, maybe. I don't know. We'll talk about it. You know, because you have a test, I might do that. It might be a good idea. Move. So I'm going to talk with Percy after this. Okay, the last thing that they want for this problem, this is the long problem on your homework. Is they're going to give you, we just figured out that f prime, is that the one we, well, we did negative 1/2 of f prime of x is equal to 3 over 2 plus x cubed, which was equal to the series n equals 0 to infinity of 3/4 n plus 1, just kidding, plus 2, times n plus 1 times negative 1/2 to the n plus 2 x to the n. Now, they say, what if I say f of x is equal to 3 over, oh, it's 3x squared over 2 plus x really, it's quite simple. This 3x, or the x squared here, is just, you can think of it as just a constant. So we're just multiplying this one by x squared. That's all we did. That's the only thing we changed. So if I multiply by x squared, that's going to be 3/4 times n plus 2 times n plus 1 and -1/2 to the n plus 2 x to the n plus 2. Now, the issue here is, this is not actually what the online is looking for. The online is looking for something with x to the n.
If you just multiply it by x squared,
That equals 2.
You can't actually do n equals 2 either because it wants it from n equals 0 to n equals infinity.
I think that
This
was
will
two.
not be on the test. If you get to that point, I'm good. I don't care. It's just the online homework wants it very specific.
If the problem is only do x squared and then x to the n.
Now,
Did you miss a negative on the 1/2? Or can I just go 3 plus 2?
that should be a negative.
Okay, sorry.
What ends up happening is you can actually subtract 2 from everything, and it ends up working out.
Is that because it's even?
The reason why is because if you look at each of the terms, if you subtract 2 from that, that's n minus 1. Subtract 2 from this, that's n. Subtract 2 from that, that's -1/2 to the n. And this one just stays 3/4. What ends up happening is, if I plug in 0 into here, I get 0 because that's a 0. If I plug in 1 into here, I get 0. So then if I plug in 2, I get x squared. And then I get 1, that's 2, so that's 2x squared. That's going to be 1/4. It ends up that these both act the same. Yes?
I mean, that's the same if you said n equals 2 rather than 0, because both first 0. So it's just a weird way it wants it.
Yeah, it's just a weird way that it wants this. I don't particularly agree with this. You recognize that n equals 0 gives me 3/4 times 2, 3/2 times 1/4, which is 3/8. That's my first term. Here I end up getting 0 plus 0 plus 3/8 x squared. Both of them give you the same thing. But doing it this way has it in the form 0 to infinity and x to the n. That's what they're looking for every time. Which is kind of ridiculous.
so generally, can you slide them back and forth and it works? What you're doing is just saying that if we take away, if we substitute n for n minus 2, then the overall, then the result's the same. Is that a general rule, or is it something that's specific to this instance?
Not positive. I need to think about it more. I didn't particularly like this problem. Now, given this, what if I gave you something like this? 3x squared over 2 plus 7x cubed. And I told you to find the power series for that. Would we have to go all the way back through everything that we've done so far? What was that?
We've done this all previously.
What you can recognize is, actually, if this is f of x, then this is f of what? 7x. So all I did was plug a 7x wherever there's an x. Guess what you can do in the series? Anywhere you see an x, plug in a 7x. So everything else stays the same. And then this just becomes 7x to the n.
So there, we wouldn't be able to do that if it wasn't 7x.
Yeah, it wouldn't be, because then it wouldn't be f of 7x. So if you're given one of these and then you're told to find something like this, and you recognize that all they did was replace x with some other term, then all you're going to do is replace x in your series with whatever term is there. Does that make sense? Yes.
My only question is, I mean, when we started this, we took the derivative of it. The derivative of that would be different because of the chain rule. So would it manipulate it all because of that? Then we have this coefficient of 7.
If we took the derivative of,
Well, because if we're solving this and we want to get rid of the 3, right? Because it's our at the bottom is raised to this cube. We want to eliminate that to get it a function of the geometric series. We differentiate, but if you differentiate with 7x from there, it would be different before.
it would, but then once you integrate to get back to here,
It wouldn't matter at all.
I think it would cancel it out. Does that make sense?
I do, I believe that will happen, just making sure.
Yeah. All right. That gets you through the first 3 problems. Oh, wow. We spent so long on that problem. It logged me out. That's sad.
Yeah, it does that a lot.
Okay, last one is you're given f of x is equal to the integral of 5t over 1 minus t squared t to the 6th. And you're told to find a power series for f of x. Now what you should recognize is this is an integral. Do you really want to integrate this? Yuck, it's nasty. But could I write a power series for this?
Yes.
Can. So I'm actually going to write 5t over 1 minus t to the 6th as a power series. And this one's actually not that bad. What's your a? 5t. What's your r? T to the 6th to the n. Now I'm going to simplify that a little bit. N equals 0 to infinity of 5 t to the 6n plus 1. Now, this is not what I want. What I want is f of x, which is the integral of that. So if I take the integral, that's going to give me f of x. I'm going to take the integral of both sides. Take the integral of that side. When I take the integral, what do I do? You got to be careful and remember that you're integrating, so I'm going to do add to this or subtract from that? Add to that. So I'm going to get t to the 6n plus 2 over 6n plus 2 times 5. And then for this one, they actually want what is, and it seems kind of mysterious at first, what is c sub 2? Why do they skip all the way to c sub 2? Is there ever going to be a t to the 0 term? Is there going to be a t to the first term? Is there going to be a t to the second?
Yes.
Yes, when? When n equals 0, you get t squared. So when n equals 0, we're going to get t squared up here, 5 over, so that's going to be 5 halves. Then we go c sub, what's the next one? It jumps to 8. Because if I put in n equals 1, this will be t to the 8th. That'll be 5 eighths. C subs, what's the next one? 14? Yeah. When I plug in 2, that's 6 times 2 is? Plus 2 is? So that's t to the 14th, which is what I'm looking for. That's going to be 5 14ths. Hey, do you guys see any patterns here? 5 over 2, 5 over 8, 5 over 14. So C20 is going to be 5 over 20. Or 1.